everyone, this is TEAM2005. Today we are going to talk about wireless charging and data transmission via resonant beam. Our senior design starting with a company called WeCharge. WeCharge want to introduce a future where power is wireless transmitted to our devices, which means that physical connection in charging is no longer needed. In their website, we found some of the prototypes was constructed. One of the prototypes is called Kick. In this model, the power is transmitted from transmitter to receiver through the infrared light. So when the power is transmitting, the LED will turn on. When anything blocks the transmission, the LED will turn off. So the electrical engineering department is looking to explore this idea. They want our team to explore and analyze the concept of wireless power transfer that can incorporate data transfer through the laser. And here is our final design. In stage 1, a control laser will target a photoresistor. This photoresistor will give a high voltage. The microcontroller chip will detect a higher voltage and then turn these two lasers on. In the receiver end, a solar cell will receive power from the transmitter and then transfer the power signal to the microcontroller. After the microcontroller detects the power signal, it will turn the LED light on. In stage 2, we are going to sense the message by using one of the lasers. In the receiver end, the NI device will grab and sample the message and then pass it to the laptop for the decoding purpose. In the laptop, we are going to use MATLAB to decode the message. Now it's time for demo. Let's first look at the stage 1, which is the power transmission. As we mentioned in the previous presentation, we have control laser over there, and then transmitter, and then receiver. Let me bring the camera closer to have a better view. These two lasers in the transmitter is controlled by the microcontroller chip here. When the control laser target on the green box, these two lasers will turn on. And then in the receiver side, after the solar cell receive power from the two lasers in transmitter side, it will light this LED up. So let's have a try. Now I'm going to turn on the control laser. And then once I target the green box, the LED should turn on. And then if I block the control laser, the LED should turn off. Remove my hand, turn it on again. Okay, the power transmission is complete. And then we can go to the next stage, which is the data transmission. Stage 2, data transmission. In data transmission, we are trying to transmit data through the laser. The message is already preloaded inside the bottom. So once I press the button, the laser will turn on and off according to the message bit. The message we are going to send including 13-bit of Barcode code and 72-bit message bit. The bit time we choose is 10 milliseconds, which means that when the message bit is 1, the laser will turn on for 10 milliseconds. When the message bit is 0, the laser will turn off for 10 milliseconds. In the receiver, we use an NI device to sample the output voltage from the solar cell and then pass it to the computer for decoding purpose. In the computer, we use MATLAB to decode the message. Let's have a try. Once the message is detected, the message will show up in the command windows here. Now I'm going to press the button. See the message show up. It's TEAM2005. Let me change an angle and try it one more time. Again, the message is show up and it's TEAM2005. Let's try the last time. Yep, still we have the message TEAM2005. In our design, we demonstrated the concept of power and data transfer via resonant beam. In our demo, we successfully transmit power and data through the laser. Thank you for watching. This is Team 2005.